All right, hi 230. This is the lesson for April 30th right here. So this is our last day of doing scatter plots, and we're actually going to be learning about what's called line of best fit or the trend line. It's basically just like a line that goes through the middle of the data. All right, so to get us ready for this, it's just a little bit of review on this first page right here. So it says the scatter plot below shows the relationship between the length of a tadpole's tail and its age in days. Which statement about the scatter plot above is true? Well, first, just looking at this right here, I can see that there is a relationship. It looks like it's a line, and it looks like it's going downward. So I would call this a negative relationship, right? So what that means as one value increases, the other value decreases. So that means I can get rid of B and C right now because both of those have to do with increasing and increasing. So let's just look at A and D. It says that as the age increases, the length decreases. So as they get older, the length decreases. I would agree. But it also says that it's a non-linear relationship. That's not true. I would call this a linear relationship. So I would say that the answer is D to that first one. All right, so this next one down here, it says Rita is a runner. She records her different amounts. Which statements are true? Select all that apply. So that means we're probably going to select more than one. Number A, or letter A. There's at least one outlier represented. Yeah, I would say so. It looks like there's an outlier at 10,2. So I'm going to circle A. There's a linear association between the distance and the time. Yeah, I would say that these basically make a line. So B, yes. There's a non-linear. No, it's not. It's definitely a shape of a line. Positive. Yeah, I would say it's positive. So I'm going to say D. Negative. No. So I would choose A, B, and D in this case. All right, looking at the next one. As you learned in the previous lesson, it is a good idea to begin by looking at what the scatter plot tells you about the data. The scatter plot below displays the data on body mass and bite force of crocodiles in the study, right? And we already looked at something like this. So number one, describe the relationship between body mass and bite force for the crocodiles. Okay, I definitely see it's going upward, so I would call it positive. It looks like it's in a line, so I would call it a positive linear relationship. So there is a positive linear relationship. Okay, this is where we're going to get into what we're actually doing today, which is the line of best fit or a trend line. 2 says, draw a line that represents the trend of the data. Comment on what you considered when drawing your line. So when you're making a trend line, it should follow the direction of the data. That's the first thing. And the second thing is about half of the data points should be above it and about half should be below. So let's say that there was 10 points on the scatter plot. About 5 should be above and about 5 should be below. Now, if it was 4 or 6, that would be fine. But you don't want it to be like 1 is above and 9 are below. That tells you that's probably not the best line of best fit. So I'm going to probably draw a line that looks something like this because it looks like it follows the trend of the data and about half of it, the points are above and about half the points are below. Okay, so I'm going to write that down. So I'm looking for it should follow the trend of the data and I'm looking for half of the points to be above and half below. All right, based on your line, predict the bite force of a crocodile that weighs 220 pounds. So what we're going to do is we're going to go to 220, which is right here, a little to the side of 200. And I'm going to go up to where my line is, and then I'm going to look over. So that looks like it would be at about 1,000, I would say. So you can use these lines to predict. All right, 19, which graph has a line that represents a line of best fit recorded in the data? All right, so I'm thinking that it's probably D. The reason why, A, it's not this one because more than half is below, right? That's not about half above and half below. B, it's not this one because it's not following the direction of the data. Yes, about half and half is above and below, but it's not following the direction of the data. C, too many is up above. D, it looks like about half is below the line and half is above. So that's why I chose that one. All right, let's look at this next one. 4. Several students decided to draw lines to represent the data. Consider the lines drawn by Saul, Patty, Marissa, and Taylor, which are shown below. For each student, indicate whether or not you think it would be a good one to make their predictions. Okay, so let's look at Saul's line. Is it following the direction of the data? Yes. Is about half above and below? Yes. So I would say Saul's line is a good line. So I'm just going to write that down. Good line. All right, Patty. Patty is following the direction of the data, but she's only got 4 points below and way more above. So I would say it is not in the middle. Marissa is almost the opposite. She's got maybe 2 points above the line and then a whole bunch below. So that's once again not in the middle. And last person, Taylor. Taylor is closer, but I would say she's got too many up top. So not in the middle. And once again, it doesn't have to be exact. I didn't go through and actually count them, but I can see like if there's 2 versus 15, obviously that's not going to be correct. All right. On the next page right here, it says, suppose the below shows the age and the price of compact cars that were advertised in the local newspaper. Based on the scatter plot above, describe the relationship between the age and the price of the used cars. Okay, so I would say that this is a linear relationship. It looks like it's following a line, and I would say it's negative because it's going downward. So I would call this a negative linear relationship. So in terms of this problem, I would say as cars get older, their value decreases. All right, then it says to draw on a line of best fit. So I'm going to draw on a line, try to get about half above and half below, and follow the direction of the data. Okay. Based on the line, for which car in the data set would a predicted value be farthest away from the actual value? How can you tell? Basically, this is another way of asking about an outlier. And yes, I would say that there is an outlier, and I'm going to circle it right there and say one outlier. All right. Last one. So it says Gokul records historical data for gas prices to the nearest 5 cents on the graph and draws a line of best fit. Okay, so notice his line of best fit. He drew a horizontal line. Would we say it's a good one? Probably not. So yes, about half is above and half is below, but it's not following the direction of the data. So let's go ahead and let's figure out why it is. Are we going to choose A? It's not the line of best fit because it should go through those specific 2 points. No, that's not true. So we can get rid of that. Are we going to say it's not the line of best fit because there could be a line drawn that would be closer to more points? Yeah, that's probably true. So let's just keep that. C, the line is the line of best fit because it passes through the points that are in the middle. No. And D, it is the line of best fit because half are above and half are below. That's true, but it doesn't follow the direction of the data. So I would have chosen B. All right, on the exit slip, you should do the top and the bottom, okay? The top and the bottom. All right, talk to you guys later.